All right, everyone, let's go ahead and get started. I'm Terry Pecars, Municipal Utilities Director for the City of Tempe. Welcome back, and thank you again for being part of our stakeholder group. This is our third stakeholder meeting. This is the meeting where we'll be discussing our process for determining the cost to provide water and wastewater services to each customer class. Again, we appreciate very much you being here and being part of this important process for us. Your input and questions is very vital to getting this study correct and addressing the concerns and questions that our residents may have, and you're representative of those various different customer classes. So we very much need your input and appreciate it as well. That being the case, as we talked about in previous meetings, please feel free to use the chat feature on Teams to submit your questions. We'll have plenty of opportunities throughout the presentation. We may pause and answer a question, but we'll definitely have plenty of time at the end as well. So feel free, and we'll try to answer your questions as sufficiently as possible. And if we are unable to answer them at the end of the meeting, we'll follow up either at the next meeting or with you via email or phone call afterwards. So with that, I wanted to talk about a couple of questions that came up at our last stakeholder meeting and address those so we can kind of have those at least mostly answered before we get into this part of the study and the various topics that are involved. A question came up last time about the idea of creating an additional customer class for residential agricultural properties, which is large lots, horse properties and such. Staff looked into this question, and after further considerations, a number of reasons why this is not something we would necessarily include in this study and probably would not recommend moving forward with future studies. And those include that we don't have specific data in our billing system for residential horse properties or agricultural properties. And also not all horse properties or agricultural properties raise horses or have farms. So these would require additional study, and there's a certain resource constraints around that as well. But also it's a relatively small number, but most importantly, we feel like we have an option that addresses that sufficiently, which is our landscape class, and it's meant for outdoor water use, so there's no connection to sewer or the return of water into the sewer system. Horse property communities in Tempe have communal corrals and tracts that receive their water from landscape meters. And again, we believe this is the appropriate class for that purpose. The second question was about why Tempe doesn't have a reclaimed water available like Gilbert and Chandler. As most of you know, Gilbert and Chandler are relatively young cities relative to other cities in the valley, including Tempe. As those cities were developing and growing, they actually master planned their reclaimed system and have wastewater plants that provide water to those systems. So a couple parts to that. Tempe, currently all of our wastewater goes to the 91st Avenue wastewater plant, which is the multi-cities plant that's operated by the city of Phoenix. Our reclaimed water plant, the Kyrene Water Reclamation Plant, is currently decommissioned, but there are plans in the future to bring that facility back online to somewhat of a limited use. But the infrastructure necessary to have a reclaimed system within a city, if not done when the city is being built, is extremely cost prohibitive. So there's a lot of limitations to being able to put a parallel system in that's following basically your distribution system. As you can imagine, we have a challenge with doing replacement of water lines currently. The amount of the cost of doing that, the cost of getting into the infrastructure, but also the disruption of the community. So as you can imagine putting in a system that was able to provide an entirely different type of water to a city. So most cities that do have this, they don't, if they do it to the new construction areas, and they don't necessarily do it to the existing buildings and infrastructure of the city. And in the case of Tempe, we're primarily built out, if you will. So again, it's a very cost prohibitive process. We do intend to use reclaimed water to some extent in the future, but having a reclaimed water system that would provide that source of water to customers is not feasible from our estimation. So I hope those answer your questions sufficiently that were raised last time. We appreciate that and the opportunity to give feedback and talk about those issues. With that, I will turn it over to our our consultants from Stantec in just a minute to get started with the presentation. But again, I want to encourage you to please use the chat feature and provide us with your questions and input, or even just thoughts. If there's something that comes up that you think would be for the good of the order, that's why we're here, and we're very much appreciative of you being part of this process. So with that, I will turn it over to Andy, Kyle, and Deb with the presentation. Thank you.
Wonderful. Thank you, Terry. This is Kyle Stevens from Stantec, and I'll be going through today's presentation talking about mainly the cost of service. And I've started every presentation with this particular slide that helps us just understand where we are in the process. And so our last get together as a group, we covered the revenue sufficiency analysis, which was fundamentally concerned with answering the question, how much money do we need on an annual basis and over the next 10 years to sustainably operate the water and sewer utilities in Tempe. Today's going to be a little bit different. We're going to move to the defensible allocation of those costs for water to customers and try to understand how customers use the system and how the system is designed to meet the needs of customers. And then our next meeting, we'll be just jumping ahead. We'll be talking about the actual rate design and the different parameters of how you design rates that customers pay. And so this is a key linkage in the rate study process. So what will we cover? For the water utility system, we're going to do a quick recap of the revenue sufficiency analysis to make sure we're all up to speed on where we ended last time. And then we're going to dive into cost allocation. I'm going to talk about a lot of system data, a lot of customer data, and analysis that's been conducted on that data in order to understand how the utility is currently sized to meet customers' demands. And that will really drive us to, at the end of the day, coming up with some initial results from this analysis that we will compare essentially the revenue that customers are paying to the utility by customer class to the cost to serve those customers. And I'll get exactly into the details of how we do that. But that, at the end of the day, is our goal, is really to understand the characteristics of customers on the system and how the utility meets those needs and the cost to meet those needs. And as always, please ask any questions, comments as we go through it. I'm more than happy to take those and talk through it and have a really interactive discussion on this. With regards to the sewer utility, a quick note. So this presentation today will cover water in its entirety. Sewer is a little bit different. So sewer, when you do a cost allocation, we're basically talking about two data points on the sewer side. It's the volume contributed by different customer classes, but there's also the strength. And by strength, I mean what's in the wastewater. And that's a very, very key dynamic for pricing wastewater flows in billing customers. So right now, the city of Tempe is starting to initiate a process to collect those strength samples from the system. This will be a really key linchpin to updating sewer rates. We don't have the data currently, but as that data becomes available in a later study at a later time, it will provide then the foundation to update sewer rates and move forward with looking at the current rates and how they might be modified. And the quick note on that is, well, we went through the RSA, or the revenue sufficiency analysis. We don't see any need in the near term for wastewater rate increases. This cost allocation that will take place at some point in the future could result in rate impacts to customers as those strength parameters are trued up to the actual values on the system right now. And so just a placeholder for sewer we won't be covering today, but this is the reason. We're waiting on some additional incoming data that's foundational to updating that cost of service. So with regards to the revenue requirements, this is the panel screenshot for water. And in this particular analysis that we went through last time with this group was really identifying all the different components that go into delivering service for a water utility such as Tempe. And so that includes the personnel, the operations and maintenance of the system, as well as the capital improvements. And so in this particular model, we entered all of those parameters in using the 21 budget and projecting out through 2030 those cost parameters. One of the larger ones being down in the middle graphic, the annual capital expenditures to maintain, replace, system assets. And what we were fundamentally trying to do is balance and create sustainability. So in orange is the cash out on the system, and black is the cash in. Works just like your personal bank account. If you're spending a little bit more, then you're bringing in on a monthly basis, and you do that for long enough, it got to come from somewhere, so it'll come from your fund balances. And the current plan, you can see how the fund balances dip over time, and in black line is the minimum target that we want in each and every year. And so while Tempe has some balances, and we looked at a couple dynamics last time, you could go a number of years with no rate increase, but when we get close to this black line, that would be a very large rate increase in order to true up these two cost lines. And so where we ended last time was taking that cost pressure and levelizing it over a number of years, starting in 2021. And what this shows is with a 5.5% increase annually, starting in 2021, this would provide a sustainable level of revenue for this entire forecast period and ensure that we maintain minimum balances, are able to invest in our capital infrastructure to provide ongoing service. What we're going to do today is, instead of looking at a multi-year period, we're going to look in detail at 2021 and the expenditures that are within the budget, the way that the utility provides service, and how customers use water. So the costs that come out of the model that we just went through, kind of the costs that we need to recover in rates on an annual basis for fiscal year 21, that we've got about $31 million, capital $1 million, and operating is $21 million on an annual basis. Kind of represents our test year is what we'll call it in the industry. So with that, I'd like to go out of the revenue sufficiency and next kind of walk through the cost of service analysis. So again, the kind of objectives that I want to keep in our heads as we go through, what we're trying to do here is we know we have an annual target of revenue we need to hit. The question we're really answering today is how is that revenue requirement split up to customers in a defensible way that recognizes the drivers of cost for the utility, but also the customer classes that are using that service. And there's a couple different ways that a utility provides service. What you'll hear a lot of times as we talk through this today are the idea that peaking costs for a water utility are a very significant driver of cost and one that we'll want to capture in this analysis. And the last point there, different customers are fundamentally different. That's why we group them in customer classes. They use water very differently. Some are very steady users. Some users can change their uses pretty dramatically throughout the course of a year to meet seasonal demands or other demands that would arise. And so that's why we have customer classes. And this analysis will help us figure out how much revenue should come from each of those customer classes. So how do we do this? Within the industry, there is a very prominent and widely published manual that essentially gives us a number or a roadmap and how to conduct this analysis. The manual is in one. It is the standard in the industry to help figure out for utilities how to allocate costs. And what we'll be going through today is there's a couple terms that will come up. So the first is kind of functionalization. And all we simply mean there, and I'm going to go through another number of graphics about this, is we need to break up all those costs in the first year into the different functions that a utility does. Thinking about the physical infrastructure, how does water flow from supply to treatment to the distribution system? And then we're going to want to take those functional costs and break them down even further into something called base plus extra capacity. And that simply means what is the base level of service versus some of the peak investments we've made in the system that need to remain there year-round to meet needs as they come on. So the water system operates on a 24/7 basis. And when someone turns on the tap, the water is there to be delivered. In order to do that, this system has to be robust and sized to meet those demands throughout the year. And so we'll be going through that functionalization as well as looking at all the different unit costs and customer-specific billing data and also AMI data, which is the automated metering infrastructure. So with regards to the functionalization, the by-the-book approach is shown in this graphic in front of you. And way I like to think about this is starting on the left side of the screen is really where a drop of water or a gallon of water enters the system. In Tempe's case, we've really got 3 different places that comes from: tap water, the Central Arizona Project, SRP, or wells. And that's coming into the source of supply that then has to be treated, disinfected, so that it can be then put into the network of pipes that are buried within the community to deliver that water to each residence, commercial, industrial, or irrigation customer. In addition, there are a number of functions that are not hydraulically related, and they're captured on the right here. So we've got meters and services. You can kind of think about this as some of the more administrative functions, the billing, meter reading, still a core function of the utility, but not necessarily related directly to the hydrology. When we talk about cost components, down here on the bottom, what you'll notice is we've got some differentiation going on with our functions to cost components. And what we're doing here is we're going to break up the utility's functions into how they serve customers. And there's 3 different ways, or 4, I should say, on the bottom here, that we're serving customers. So in the first, we call this average day demand. And this just simply means that we're meeting the average level of demands across the system for a year. That is typically provided by the source of supply and partly in the treatment. Now, if we move to the right one, we've got what's called max day demands. And these are a little bit different. So what we're really talking about here is on the system, there are periods, typically in the summer for Tempe, in which the demands on a daily value hit their maximum. And in order to meet that, this system has been sized and invested in to provide that demand when it's demanded on that day. And that typically falls on part of the treatment facilities are upsized to meet that, as well as the transmission and distribution systems. And then furthermore, one additional demand that comes on the system is peak hours. So oftentimes we've not only got to serve those average demands, that max day, but then also on the system, there can be really significant peaks that occur on a much shorter time period. And we call these peak hour costs. And this can happen in the heat of the summer when everybody turns on that water. We've got to be there again to meet those demands. And those are really significant. We have to make sure that the system is sized. That typically occurs on the distribution and transmission side of the system. So it's typically the idea that those pipes that are in the system have to be large enough in order to meet those demands and maintain adequate pressure when those demands come on the system. And then finally are the customer-related costs. I mentioned, billing, meter reading as being prime examples. We look at that as kind of a per customer type unit of service. It doesn't scale by the amount of gallons you use is another way to say it. It's really on how many different customers we have on the system. So how do we break up the cost? Tempe's budget in fiscal year 2021 has roughly 800 or so individual line items and numerous departments. And so we've just put a screen capture up here of our model that has each and every line item in it. And what we've done is before this meeting with the stakeholders today, we've gotten with Tempe's staff with all the relevant departments and functions and talked about each and every one of these line items and departments to come up with the best factual and data-driven way to break up the cost in fiscal year 21, which is shown in this column, to our different functions that I just talked about. So you can see, for instance, in customer service, we're going to break that and send it all to meters and services. But depending on the exact line item and the department, we've used a number of different ways or factors to take the costs that are in 21 and turn them into the functional cost that we just talked about in that diagram. And so it's a pretty tedious process to go through, but it results in a very defensible split of those costs into the functions. So going back to my diagram, what I'd like to do now is fill in up top in the gray section the output of this first step in the analysis. And so in fiscal year 21, which is next year for Tempe on the fiscal basis, the supply cost on an annual basis, which includes all the operation, capital, debt service, is roughly $8 million for supply. Treatment is about $25.1 million. Pumping, transmission, distribution, storage is roughly $22.3 million. And then billing, meter reading, and customer services is about $4.2 million. So in total, we're talking roughly $59.6 million, an annualized cost that we have now functionalized into these functions. You will notice, typically, and this is very normal when we do this process, treatment and the distribution, those buried pipes, there's where a lot of the annual costs of the system are related to. What we will do next is take those functionalized costs and we're going to convert them to the cost components, the base plus extra capacity, those average day demands, maximum day demands, and peak hour costs. And how we do that is understanding some key components of how the system is delivering service. And so in the graphic below here that I've animated, we have gathered data from the system's production and how it's delivering water from the treatment and reservoir systems to the distribution system to be distributed to customers. And a couple things come out here. So right now, this in blue is 2017. This is the annual flow rate hourly in millions of gallons daily. And a couple of things I just want to point to as we go. This is starting on the left side of your screen is January 2019. And as we move across, it goes throughout the calendar year. And so a couple of things are pretty evident when we put this up. In the winter months, going into spring, the demands are relatively steady. You'll notice the peaks in flows and the valleys in flows are relatively close to one another. But on Tempe system, as you start to move into the shoulder months and to the summer months, we do see a noticeable increase in the demands placed on the system. Not only the average, as you see kind of the width of this go up, but you also see big changes in the peak hourly rates. And you'll notice in those summer periods, the demands can really spike. And we will see the demands increase pretty dramatically from the winter months. And the system has been invested and has capacity to meet those demands that occur. And that's a really critical concept as we go through this cost of service. Just because these demands are lower in the winter months on the front of the year or on the back, the system's capacity has to be sized and invested in to meet the maximum demands in the summer. And so that capacity is there year round. If I layer in a couple of years, we've got 2018 here in orange, and in gray I've layered in 2019. And the reason I've put a couple of years on there is because given Tempe's regional location and its seasonal weather dynamics, as part of this analysis, we thought it would behoove us to use a couple of years of data, because in one year you might have a pretty dry year, one year you might have a wet year, and that can be a really big determinant of how these peaks evolve when we go into the summer months. And so for the purpose of this cost of service, we've used the average of the last 3 years that we have data for to try to represent the average demands of meeting customers' demands over the course of a year. When we look at kind of the average, just to give you an idea of that peaking, our average is down here in the 40 million range or so a year. Those peaks, though, when we come up here, are well above 80 million gallons a day, so almost twice or over twice the average demands on the system occur in some of these peak hour periods in the summer months. So critical dynamic, the system and its cost are sized to meet those. Up in the table up above, what this shows is the quantitative way that we're using this data that we've derived from the production on the system. And so from the source of supply, again, going back to my functionalization, 100% of those costs that we were able to identify in Tempe's 21 budget are going to be assigned to the base capacity that we will be meeting throughout the year. But as we move to the treatment function, what you can see now is there is some fractionalization in how we're going to spread that cost. And so 67% of it will go again into the base. That treatment is there to meet base demands. But then we know from the production data that there is some maximum demands happening on the system on a max day basis in the summer. And based on the ratio of the average to the maximum day, we're coming up at 33% of cost in the maximum day category for treatment. When we go to transmission and distribution, I mentioned a second ago that we've really got three components there in the way that this is meeting demands. It's got some base, and we're delivering base demand there, 54%. An extra day, our maximum day, about 26% of this cost on an annual basis. And then finally, because this is really fundamentally where we're serving those peak hour costs, we've got an additional 21% of those annual costs for transmission and distribution in our peak hour category. And this will become critical as we move to the next step in the cost of service analysis. This is fundamentally thinking about how the utilities costs are generated and derived to meet customers' demands on a yearly basis. Now, from the customer, I mentioned we're going to take those customer costs and we're going to map them to customers. So there's no splitting of those costs. Those costs really are a function of how many customers are on the system, regardless of the demands that they draw or place on the system. So if we take that exact same graphic, I've got the functional cost up above. What we're going to now do is on the bottom side, apply those factors I just talked through that are based on the production data to understand how this cost looks from a base max day peak hour cost standpoint. And so when we start to convert that down to the cost components, the average day cost is $36.9 million annually. The max day costs are $14 million. The peak hour costs are $4.5 million. And then the customer 4.2 to 4.2. It's the exact same total we just talked about, but it's essentially coming up with how we're functionally invested in our system and expending costs on an annual basis to meet these demands. So now what I'd like to do is we're going to move out of how the system size, and the next few slides we're going to try to talk through the data that we used to connect the dots between system production, the gallons we're putting into the system, and who's using those gallons on those same intervals that we just talked about. And so in this first graphic, this is what we're really used to looking about and thinking about for water usage. And this is the monthly billing data for 2019, and I've included in here the different customer classes. And historically, this is the kind of data that we've had for a utility. We've had 12 data points for each household or each commercial connection, because historically it's really relied on a meter reading process where a physical person has come out and read that meter to determine how much water was used in the last 30-day period. And so in this graphic, a couple things that are prevalent as we talk through it. In black is the single family classification. Again, starting from January, moving throughout the year, you can see a really clear change in demands as we move into the shoulder spring months, into the summer months peaking, and then falling off again down in the fall months. So there's definitely some seasonal usage in that customer class. If we say take, as an example, multifamily, another customer class, looking across a time spectrum, different total level of usage, not quite as much peaking. And so what we're really trying to do here, and what we're going to continue to drill down on the next few slides, is understand and quantify each of these customer classes and how they're using Tempe's municipal water system. In addition, we've got commercial. You can see a commercial, it does display some of these seasonal peaks. In the dark gray is industrial. Industrial is relatively flat throughout the period and driven oftentimes by different demand drivers. That's really sometimes thought of as a production class, where there's some kind of production going on that drives the water demands. And then last, we've got in the light gray, the landscaping class, which is primarily serving outdoor demands of some kind or seasonal demands. And that's really clear in our data. So you can see in the winter months moving into the spring and summer, again, some of these peak demands are coinciding with that production data that I just showed you a second ago, as this class increases and then again falls off if we move into the fall months. Now, in Tempe's case, and in this particular cost of service study, we have another set of data available to us. And this is the first time that we've ever been able to look at it in Tempe. It is relatively new in our industry, being the water industry, and you've heard me refer to it as AMI, it's automated metering infrastructure, and it's just taking essentially that analog process that I just described where a person's reading a meter and bringing that into the 21st century and digitalizing the collection of data for each and every meter that's on the system. And so in Tempe's case, this was just completed over the last few years. We just got essentially a full year of customer data to be able to use this. And to kind of give you an idea of this data, it's really fundamentally one layer underneath billing data. It provides a very distinct set of data. From those 12 points I mentioned, which were based on an individual reading meters, to the digital version, these points are endpoints, AMI endpoints that Tempe has invested in. They're reading hourly. And so we've essentially gone from 12 points on each meter to 8,700 points in each year for each meter. And so this is a vast expansion of the data available for us to truly understand customers' usage on the system and ensure that we're taking that into account as part of the rate study, such that customers are paying a fair share for their use of the system. And this really, as I go through this next slide, it's really a completely separate analysis for cost of service that we've conducted. We actually have a data scientist on our staff to help us do this because the data is such a large, voluminous set to go through and get these data points out, but they are a critical part of this analysis and a critical observation that allows us to really truly understand how people are using the system. The graphic on the bottom shows us the relative customer percentage that's included in the analysis. And what I mean by this is when we go through that data set, we need to perform a number of processes on it. So we need to clean it, organize it, and analyze it. And typically as part of that analysis, we have to exclude a number of data points or accounts from the overall analysis. And there's plenty of reasons for that. So, some of the ones that come up is if a car gets parked over the meter, that meter oftentimes has trouble communicating back its usage for that day. Doesn't affect the overall billing because billing, again, is still monthly. So as we get the next read in a couple of days, we can true up the data. But for this type of analysis, we really want a continuum of data for these meters so that we can understand exactly what's occurring on an hourly level, on a daily level, and match that up back to the system production. What this shows me, though, at the high level, is we've got a very, very representative sample of each of these classes, and in most classes have the vast majority of customers with clean, good reporting data that we can use as part of this analysis. So a deep dive into customer data. What I'm going to show you on this graphic, and I'll bring up single family, this is maximum daily observational data from 2019. And so I'm going to take some time as I go through these slides. We're starting on the left here on the x-axis, again at January 1st. We're going through the entire calendar year of 19. And the values that you're seeing here is a ratio. And so this represents the peak day demand in each day divided by the average day for the customer class for the entire year. And so what this shows you is, again, as we go through single family, as we go through the winter months, we see those kind of relationships below 1, meaning that the demands on the daily basis are below average. But as we go through the summer and seasonal months, those demands, again, very coincident with what you saw a little while ago on the production data, start to rise, and we see our maximum of values for the single family class take place in the middle of the summer in the seasonal irrigation months. So this is key straight data out of the system that tells us how this customer class is using the system on a max day standpoint. Now, if I bring in multifamily in orange, you can see that customer looks a little bit different. We talked about, again, it doesn't have some of the same demand characteristics. And from a daily standpoint, max day, it's much steadier throughout the year. There is a little bit of an increase in the summer months, but relatively steady as compared to single family. If we bring on the commercial, and I know this is a lot of data as we start to pile one on top of another, but the commercial shown in gray here has similar seasonal trends. You'll also notice in this AMI data that I've just brought up, a real clear kind of heartbeat pattern here, right? And what you're seeing in the data there is the work week dynamic. So you're seeing 5 days on, a weekend, 5 days on, a weekend, 5 days on. So again, kind of validates when you see this data, the real world measurements that are coming through this data being displayed on the chart right here. Takeaway for commercial, though, is again, we do see some of those peak demands occur within the summer, and this data allows us to get the observational amount of those demands in the summer months. This is the landscape classification in yellow that I've now layered on, and this one shows on a max day basis some of the larger demands and changes in demand that we see on any customer class. And I think that's to be expected largely. If you think about this customer class, these are really meters that are serving outdoor uses. And so during those summer months, when your seasonal demands are up, these meters are meeting that. You can kind of see as well on the back end here, my understanding in your local areas, there's some overseeding dynamics that take place kind of in the fall period. And that really kind of shows up clear in this data as the demands drop and then actually come back up a little bit here in the fall. And then the last one I've got is the industrial dynamics. Again, you can see that weekly trend in the overall data, but from a totality of a year standpoint, relatively flat, some peaking going on in the summer months as well, but not as expressive as some of the other customer classes that we talked about. With this data set, just to give you an idea of what we're going through, it's about 11 million data points to get this graphic created on a daily basis. So what I'm going to take next to a really deep dive. This data set, by comparison, is about 263 million data points from all of the meters that we were able to use for each customer classes, and they're reporting on essentially an hourly basis. So what this shows again is starting on the left and moving throughout the year to your right, 2019 from from January to December. And we're showing a ratio. So we're expressing now on the numerator the peak hour values that we were able to see for each day, divided by essentially the average values that we see across the year for each customer class. And what this shows is, again, on single family here in blue, as we go from winter to the seasonal months in the summer, those values increase, meaning that the usage on the hourly basis, the max hour, are higher in the summer than they are in the winter months. So there's some seasonal demands that come online that Tempe system is meeting in that time period. If I add in multifamily, you can see here down at the bottom, it does have a little bit of an increase in the summer, but the relative change throughout the year is much less as we go through from January to December. I'll add in next the commercial, which shows on an hourly basis a little bit of a change in the summer months. There's definitely some increased hourly usage, max hourly usage there as compared to the winter months. The landscape meters, again, due to their demand characteristics and what the water is used for, will display a relatively large change. So as we go from the winter months into the spring, into the summer, we can again see that ratio rising as those peak uses occur on the system in the summer months. If we include industrial down on the bottom in green, that shows throughout the year, much like we did on the max, relatively steady peak hour usage here. Not too much of a change, a little bit more in the summer, but not as expressive as some of the other customer classes again. So what does this mean? How do we use it? This slide right here, I'm going to take a little bit of time on because this is really how we're converting that graphical data that we just talked about back to dollars and customer classes. And so on the left here is I'm going to walk through this table. We've got our customer classes going down by row. And across the right, I'm going to talk about the different types of demands in that base plus extra capacity framework we've been talking about of how the utility is servicing customers. And so number of accounts, talked about this a little bit before, single family is really the dominant classification from a number of accounts standpoint. And if I go down to the chart below, what we're doing here is for each of the customer classes, we're stacking in dollars and millions of dollars the different components of cost. And so I'm just going to take customer cost and the number of accounts first. They're shown down here in this gray color. And so as you would imagine, with 34,000 accounts, we're essentially weighting each account with the same for the billing and the customer service function. You're going to see a larger chunk of gray here on single family than you would see on any other customer class. It's proportional to the number of accounts that the utility is serving. Now, when we talk about the average day demands, we're in this next column, and we can see as we look across the customer classes and go down, there's varying different levels of average day demand that these customers place on the system. And so we're going to take that base cost that we identified is about $35 million before in our first part of our analysis, look at the proportions here of that usage, and then in the graphic below, spread that average day cost equally to each and every customer class based on the demands that they placed on the system. And so this green bar here represents for each customer class their average demands that they place on the system. And you can see it varies essentially based on that average usage for each customer class. The next two are the extra type of cost. So we've talked about the fact that peaking is a really significant dynamic on Tempe system. There's a lot of investment that's happening on the system, installed capacity that we have year-round to meet these demands. Now that we were able to use the AMI data to parse through millions of records of usage, we can then proportionally distribute that cost, and I'll take max day first, to each and every customer to ensure that they're paying their fair share of their observed usage. And so in blue is the max day cost, and you can see, for uses such as landscaping, commercial, single family, that bar is a bit bigger than it is for multifamily or industrial. And that goes very much back to those few charts we just talked about. When we looked at those customer classes, the peaking dynamics were not so large from the seasonal usage standpoint going throughout the year. And so again, this syncs up very much with that observational data and the production data that we see on the system. The last category we'll talk about is the very top level of demands. Those are those peak hour demands when everybody opens the faucet at the exact same time, and our system has to meet that and has to maintain pressure. These values represent that extra capacity by customer class. And down in the graphic in yellow, we have then layered in proportionally for each and every customer class the amount of that peak hour capacity that they're using on Tempe system. And so again, it's going to follow somewhat of a similar trend to what we saw before. Single family, commercial, landscaping have some very definite and very illuminative trends as we look throughout the year. We can see those demands change. This structure is ensuring that those customer classes are paying their fair share for that, as well as industrial and multifamily. You can see there's slivers on here that do have small amounts of change throughout the year. So you can see the yellow that would get layered into here. Main thing being is we're treating every customer class equally based on their observations of data that we have on the system. So the next few slides, I'm going to get us to the ending answer. And I know it's a lot of information to get here, but it's really important to get through all those base steps, talk about the data, how we're using it. What these next few slides represent are the key takeaway. And it's a high-level takeaway as we start to wrap up all those dollars. What we want to do now is go through these next few slides, compare what each customer class is contributing to the system versus what the cost of service is based on the analysis we just went through. So a quick reminder, this graphic on the first one is showing the entire system. And as we've talked about in the revenue sufficiency analysis, for fiscal year 21, we're showing or calculating a needed increase in revenue of 5.5%. And that is based on the overall needs of the system over that projection period that we went throughout to 2030. What that would mean is that the current revenue in total is roughly $50 million. To get to cost of service in 2021, that'd be $52.96 million. And so we need more revenue overall. The question is, with these orange bars, based on how customers are using our system, how should this $52 million be distributed? And what does that look like compared to each customer class current contribution? A quick note as I go through this, and I'll talk about it more when we get to the multifamily, we're currently showing revenues based on current rates, but 2021 billing classifications and units. And that's a key distinction I'll talk about in a second. In addition, on each slide, there's going to be this donut chart off to the right. And this is going to show us the relative proportion, much like we just talked about a second ago, of the different cost components that are attributable to each customer class and they vary depending on how that customer class uses Tempe system. So I'll first go through single family. Single family currently on an annualized basis is contributing about $18.43 million in revenue. The cost of service is showing that it should be about 19.17 in order to ensure that this customer class is paying for its fair share of usage based on the observational data that we have. And so what that would mean is the amount of revenue would need to increase by 4%. And the way we use these results is they're indicative. So they help us understand where a customer class is, how they're currently paying versus what the underlying cost of service is. And what we don't want to see over a long period of time is big variances between these two. And we'll talk about, mainly as we go into the next step of this rate study, how to use these findings. But the real key is here, we wouldn't want to go for significant amounts of time or see a growing gap in the amount of revenue being paid by any customer class and the cost of service that customer class requires. So with regard to multifamily, I mentioned that note, and so one of the key notes as I talk through this is the city went through a significant audit process this spring in which a number of multifamily accounts, roughly 2,800 or so, were reclassified from multifamily to single family, and that's because they were essentially an individual meter to an individual dwelling unit, and so they were best reflected in the city's definitions of a single family customer class, which changed the makeup and complexion of this customer class. Now, what we're showing currently is on an annualized basis, this customer class is contributing $7.59 million to the system. The cost of service, though, based on the observational data out of the AMI, which showed that the cost to provide service to this customer class is $6.81 million. So what this is showing is that's a reduction of 10% from what they're currently paying right now. With regards to commercial, the current contributions in revenue are 12.49. The cost of service is 13.20, which covers all the different components of their service, including average, max day peak, and customer. That would show a change from current to cost of service of 5.7%. Industrial results. The industrial customer class is approximately $3 million in current revenue. The cost of service is 3.28 for fiscal year 2021. Again, that includes the observational data with regards to the different ways this customer class is using the system. That would show that there is a change here from the current revenue to the cost of service of 9.7%. With regards to the landscape meters, the current revenue is $8.7 million. Cost of service on this one is 10.57. And so what we're seeing here is there's a change of 20.8% between these two numbers. That's being driven primarily as we go through that observational AMI data of the identifications of some of the key peaks that this customer class is placing on the systems and how Tempe's annual costs and services are meeting those peaks. And so that's what's really driving when we see these big changes between the current revenue and the cost of service. And so with that, I'll end the formal presentation. Just a quick summary before we open it up for questions, discussion. We've now met 3 times. We've covered Rates 101, revenue sufficiency last time. And today we really went into detail with the cost of service. The last meeting and final meeting is really the rate structure workshop, talking about how do we take all of this and put it into the actual rates and charges that are assessed for customers' uses of the system. And so I guess with that, I'll turn it back over. Would be Steve to get questions, comments.
Andy or Kyle, we do have one question out there. Could you talk about how irrigation was included in the scope of the study?
Yeah, absolutely. And so it's not necessarily irrigation it's separately. The best way to think about this is that we're including every type of demand on the system in our analysis And because Tempe has invested in a state-of-the-art AMI system, we're able to get the real data, and we're really able to understand on your utility system how these demands are placed on the system. And in the landscape class is maybe a great example on this chart for the hours of how some of those outdoor seasonal irrigation demands potentially impact the system. And so it's included as a demand type in our analysis that comes all the way through from the production data, seeing those seasonal trends, the actual demand data that we see on AMI. And then as I just went through those ending results, we can see for customer classes where the peaks that are identified, such as landscape, are higher than what's currently being recovered. There's some differences in the cost of service compared to the current revenue levels.
Yeah, and Kyle, just to maybe help kind of further clarify, because you probably can't see the chat, the question I think was really specific to flood irrigation. And so what Kyle described is kind of how we handled irrigation that happens through potable water meters, but irrigation through flood irrigation, we've done a separate, very specific cost of service analysis for that. That's identified what that cost is and compared the current revenues to that for city facilities as well as flood irrigation customers. I think there's going to be some policy discussions for council to discuss what level of cost recovery they would like those flood irrigation rates to capture, recognizing what rates are providing today, and then some of the potential ancillary benefits of flood irrigation from an aesthetic value perspective, to give guidance to this study about what level of cost recovery should the flood irrigation rates reflect, and over what time period should that be established. In the prior study, council had approved flood irrigation rates that captured 50% cost recovery. The costs have changed a little bit, so we're not quite at that mark today. But I think that's going to be an important discussion from a policy perspective with council that I think maybe Terry or Steve, you may want to further elaborate on from a process standpoint.
That's correct, Andy. Yes, that's one of the study results that we will be going to council with, to provide them with the information and the data. And then, as you mentioned, that would be a policy decision that would have to be the consensus of council if we were to make any adjustments to that program, or keep it at the current level, or even potentially plan for a longer term phasing in of potential full cost recovery. So thank you for that question.
We have another kind of backup question to that. Is flood irrigation water treated?
Flood irrigation water is not treated. Flood irrigation water is surface water coming from Salt River Project that is distributed through a various system of laterals, but it is not treated potable water.
Okay, where are most landscape meters located? I am single family and do not have a separate landscape meter.
This is Steve. I'll jump in on this question. Landscape meters are primarily HOAs, common areas. Commercial and multifamily properties have outdoor landscape meters. The reason for landscape meters are they're not connected to the sewer system, so you're only billed for your potable water use and not your sewer system. A majority of our parks are also fed by landscape meters. We do have some parks that are on raw water that get water from SRP. However, landscape meters could be in any other customer class, given that they pay for them to be installed.
And the message back is thank you. If anybody has a question, we encourage you to use the chat. We'll give you a few more minutes here, or seconds here, to type a message if you have one.
Mary, this is Steve again. I just want to bring up one item that Stacy had requested in our last meeting, but it will actually be provided in the August stakeholder meeting when we get into rate structures. But we will have commercial and industrial cost comparisons at different volumes for those customer classes as well when we meet in August.
Thank you, Steve. Any more questions from anyone? Terry, if you have some closing remarks, maybe we're ready for those.
Yeah, it looks like we're right at about an hour, and so not seeing any additional questions coming through on the chat. I just want to, again, thank everyone for their participation in the process. We very much appreciate your questions and input. Again, there will be additional opportunities. We've got another stakeholder meeting upcoming, as was mentioned. I just encourage everyone, if there's questions that come up in the meantime, you can certainly reach out to Steve directly, and we will answer the question and then share that with the group as well. But again, your involvement in the process is vital, and we very much appreciate the time that you have taken to be part of this process, both prior to this meeting and in our future meetings. So thank you very much. And with that, if there aren't any additional questions, we will conclude. Thank you.